start over? Can you hear me now? Hello? So welcome to the San Francisco MySQL meetup. Our sponsors tonight, of course, are Craigslist. Oh my God, it was not pizza. For somebody who cannot eat pizza, I was very excited about the food. I hope you guys enjoyed it. And not only did they bring good food, they also supplied the beer. And for people like me who can't drink beer, they supplied wine. So we have wine and beer, non-alcoholic. Craigslist is so good to us. And they brought really cool swag. I don't know how many of you realize that the beer openers are flash drives. Oh my God, one cannot have enough flash drives. So I'm very excited about that. Our other sponsors for tonight are, of course, O'Reilly, which gives us books that we raffle off. Percona is our original and long-standing sponsor. Lithium, who is hosting us and pays for Mike and Darren's time, are our other sponsors. So I don't really have to yak anymore. I'm opening it up to anybody who wants to stand up with an announcement. You are free to announce, but let me run over and put the mic in your face. Does anybody have an announcement? Okay. I'm handing it over to Jeremy, and I'll shut up.
Hello, everyone. As you heard, my name is Jeremy Zawodny. I work at Craigslist, and I'm going to talk about our real-time search infrastructure. Before I go too far in, I'll just reiterate what you heard before. If you've got questions about what I'm talking about while I'm going through the presentation, feel free to raise your hand or interrupt me. If you've got questions sort of about technology at Craigslist but not quite on topic, just hold it till the end, and I'll be happy to answer you. How many of you here work with MySQL as a DBA on a daily basis? Okay, and how many from sort of a developer point of view? Okay, and just curious, how many of you have used Sphinx at all before? A few people. Elasticsearch, Lucene, or any of the products built on top of Lucene? Okay, so we have kind of a real mix of experience here. I'm always curious to know who I'm talking to before I get started. So who am I? I've been at Craigslist since about mid-2008. That's about 6 years now. When I joined, my first major project there was to fix search. And it's either success or failure that I'm still working on search there. So I'll explain some of what that journey looked like in this presentation. I work on a bunch of different technologies. Several people I've talked to and just milling about today asked about, well, do you use this, do you use that? And the answer is we tend to use the best technology we can find for a particular job. So personally, I use a lot of Perl. I work on search stuff. I've worked on MySQL stuff. I've used Redis for various things. I've used MongoDB for various things and just do other back-end data type things. So we tend not to be terribly religious about sticking to a particular technology. It's more a matter of getting the job done and trying to do it well. Before I was at Craigslist, I worked at Yahoo for about 8.5 years, and before that I was at Marathon Oil. I also wrote the first edition of High Performance MySQL for O'Reilly, which seems like eons ago now, but I did work on that and attempt to sort of write down everything I learned about MySQL performance at the time because no one else had written it in a book yet. And so that's the kind of quick who am I. A little bit about Craigslist as well, because I always get questions from people about Craigslist. Whether I meet someone on the street who's just a user or talk to someone in more of a technical context. So we have a very engineering-driven culture. We don't have product managers or marketing people or any of that kind of thing. We actually have something unusual. We have users who tell us what they want, so we just try to build the things that users want. And we try to keep that feedback loop working. We've got less than 50 employees, which I think is still accurate. We're all self-hosted on our infrastructure. We don't do any cloud stuff, no virtualization stuff. We're kind of old school in that we have data center space with actual physical hardware in it and actual physical network cables and actual physical network switches. So if you have questions about running this stuff in a cloud environment, I'm probably not the best person to ask. We are a multi-data center. We have 2 active data centers that we run our services out of. And as I said, we're very driven by user needs and feedback. We try to pay attention to what people are doing on the site, what's working well, what's not working well, and improve the things that people are asking for and just try to make things better. That's a big part of what we do now, is just trying to incrementally improve things. People often will joke that we don't, we've been the same for 10 years or whatever and haven't changed anything and that kind of stuff. And the reality is we're changing things all the time, but we can't make dramatic changes because it would surprise a lot of people if we did that. So I'll give you one example of that. This is what our search interface looked like in 2014. And actually, I'm going to stop right here. I forgot to ask a very important question. Is there anyone here who doesn't know what Craigslist is? Okay, so this is not a surprising looking thing to any of you. You come to Craigslist, you search for something, and you find what you're looking for, hopefully. A lot of times it's a house or someone selling a car or a computer or a digital camera or whatever it might be. This is what our search interface looked like a little earlier this year. You come in, type Honda Civic, and you get a list of cars back. It, to a lot of people, like I said, hasn't changed in 10 years. Well, here's what it looks like today. Same kind of thing, right? You put some text in there, and you get some results back, and oh, there's little pictures there, and oh my God, there's new stuff. You can actually select size, type, drivetrain, fuel type, transmission, title status of a car, is it salvage or whatnot. We've actually been adding a lot of new features to search over the last few years, and we're going to continue doing that. And part of that is because we've got what I hope is a solid infrastructure built up now that we can keep iterating and keep adding features and not have to worry about it falling apart. How many of you have seen the maps that we have on Craigslist? Good, so about half people here have seen it. Very useful for some categories. If you're looking for an apartment or trying to figure out where a garage sale is or something like that, you can flip over to the map view and just visually browse around and zoom in on neighborhoods and things like that. That was virtually all built by one person over the course of several months a couple years ago. That's Dennis, who's sitting right over here. He put together our maps infrastructure, which I think is great. Someone comes into the company and is like, I want to work on this, and built something new. So what I'm going to talk about, challenges of search at Craigslist. Why is the problem we were working on difficult? A little bit of the history of kind of where it was and the evolution we've gone through to get where we are today. Some of the lessons we learned along the way, and then I'll answer questions. So I think the single biggest challenge with doing search at Craigslist is really a combination of two things. It's the indexing rate, the fact that we've got data coming in all the time, and the churn rate, which is how often the stuff that has come in is being changed or deleted. A lot of things like message boards, for example, if you've got a message board service that you're running, there's a lot of discussion happening. People come in, they write a post, you've got to index that, but a lot of services don't even give you the ability to edit that. So once something's written, it doesn't change. On our site, it's a little different. We're getting thousands of postings per minute, which is a good volume of stuff coming in. We are getting postings that are constantly being updated, refined, tweaked, and deleted. And part of that is, what's the half-life of a posting on Craigslist? And if you ask me that question, I can't tell you the answer because it's specific to the city you're in, it's specific to the category you're in. It's probably even specific to the time of day or week it's been posted, depending on the city and the category you're in. But it's not uncommon in some categories for a post to go up and 10 minutes later it comes down. A few years ago, I was moving and had a bunch of stuff to get rid of at my house, and I'm like, I don't know what to do with this. I want to get rid of this. This old couch, this freezer, whatever. And I put a lot of it up in the free category on Craigslist. And you would not believe how many responses you get when you're in a major metro area and have some free stuff to get rid of. You put the post up there, 30 responses later, you're like, it's only been up for 2 minutes. I have to delete it because I'm sure someone's going to come pick up my stuff. So that kind of stuff happens all the time. People find a good deal, whatever they're selling, whatever they're advertising, people jump on it and they either delete the posting or they start getting a whole bunch of people emailing them and saying, hey, you forgot to put some information in your posting. How old is this? What condition is that in? Whatever. And so there's stuff is changing, so we're having to re-index things. Added to that is our regular traffic coming to the site. there's a sizable percentage of our traffic is people coming to the website, putting something in the search box and hitting search and trying to find what they're looking for. And that's happening at a relatively high rate. We're seeing typically 4,000 queries per second at peak, sometimes higher, sometimes lower. But 4,000 queries per second is kind of a baseline we hover around during the busy time of the day. And we've been able to deal with that pretty well. And I'll talk about how we did that. But one of the things that's happened is that we've added new features. Some of these features, and I'll talk about this a little bit later in more detail, have become sort of query multipliers. So we introduced a feature earlier this year where you would do a search on Craigslist, and in addition to seeing all the matches, a little link appeared at the top of the page that told you there were matches in other categories. If you were searching a very broad category like for sale, you may search for sale for a term like Honda, and you might have matches in cars for sale. You may be Honda motorbike and Honda generator and all sorts of other things that Honda might make. So we added a feature to put a link on the page so that you could see that there were matches in other categories, and we'd list all the other subcategories and put a count of the matches in there. Well, the simple act of adding that one feature nearly doubled our peak query rate, because every time someone did a search, we always ran the search twice. We ran the search, and then we ran a version of the search that in SQL looked like a count with a group by on it, because we wanted to group by category and count how many were in there. So suddenly, we're instead of doing 4,000 per second, we're up here at like 7,500 or 8,000 per second. And that's one of the things we think about when we're rolling out new features is how many more queries is this going to be sending, and how do we handle that? We're actually in the middle of testing a feature like that right now and kind of watching the numbers to make sure nothing blows up. So another challenge is figuring out how to spread the load. We want to build these features, we want to make search better, we want to make it more useful, and we need to figure out how to spread the load. That means we need to deal with sharding and partitioning schemes for the data. So I'll talk about how we did that as well. So the brief history of what search looked like at Craigslist. To accurately complete this slide, I had to get input from our CEO, Jim, who knew about what version 1 of search at Craigslist actually looked like. Because when I came, it was actually search 2.0 we were already on. So it started, back in the early days, it was Perl and DBM files, because everything was high tech back then. Version 2 of search was MySQL Full-Text. How many of you have ever used MySQL Full-Text? How many of you still use MySQL Full-Text? 2 people. All right, that's 2 more than I expected. Version, oh, then is it the new stuff or the old stuff? New stuff? New or old? You use the old stuff. All right. All right, we have a winner here. That's what Craigslist Search 2.0 was, basically. It was the old MyISAM tables where you put a copy of the data in there and you get full text indexing on it, and a host of other problems along the way. Version 3.0 of search was moving to Sphinx, which I'll talk about. It was a master-slave architecture that we put together, and that lasted for about 3 years. Search version 4 was something we called autonomous Sphinx. Basically, the masters and slaves, the notion of master-slave went away. And then Search 5.0, which we're on today, which launched last year, was real-time Sphinx. And I'll talk quite a bit about that. So this is all about evolution, like I've been saying. Our needs and desires are constantly changing, which is a way of saying we want to give users more features. We want to respond to things people are trying to do. The good news is that Sphinx, which is the search software we settled on, has also been improving along the way as well. The other thing that's helped us out quite a bit is the hardware is more capable. Everyone loves Moore's Law. You wait a couple of years, you can buy hardware that's far more powerful than you had, and you're not going to be paying extra for it. And we try to be on a good hardware refresh cycle where we're upgrading our hardware on a regular basis, which means we can take advantage of those things. We're also trying to learn from previous mistakes. Like I said, we're not using MySQL Full-Text anymore. It's also fun to do new things. It's fun to work on something new and put something together you can build from the ground up. And the last and probably most important piece was searching is more important than browsing on Craigslist. We, for a long time, didn't really look closely at the data to understand how much of traffic was coming from search, how much of it was people browsing, And look at those percentages and look at user behavior. When we spent the time to really look at the data, it was one of those kind of revelations where you said, wow, okay, we should really focus more effort on this because people are trying to do things with search that we aren't making easy. They are doing things with search that we do make easy, but we can make them even better by adding more features to them. Giving them filtering ability they didn't have, giving them sorting abilities they didn't have, and so on. So that's been a large part of what's been driving the evolution in the search features we've offered in the last few years and the new things we've been building. So I mentioned MySQL Full-Text. When I showed up at the company and that's what was being used, it looked a lot like this. Things were constantly on fire, oftentimes teetering on the brink of falling over and collapsing entirely. And it was very common for MySQL Full-Text to be the bottleneck. It was a problem. Like I said, it was used up until late 2008. There was this manual sort of sharding scheme because you wanted to make sure that you didn't have too much data in a hot index or too many hot indexes in one single cluster. So there was this mapping scheme to make sure you could figure out for a given city in Craigslist the data lived over here, and for another city it lived over there. And even with all that stuff in place, the performance was poor at times. It was very easy to sort of launch a denial of service attack against yourself. And that happened on a regular basis. And the unfortunate thing is because of the technology at the time, it's not like performance started to just trickle off. Things would sort of hit a wall and just fall off a cliff. You were doing a couple hundred queries per second, and then the next thing you were doing 0 queries per second because something was locked up. And that's obviously, that's bad. No one wants to see that. The MySQL Full-Text also had very limited query syntax. There's a lot of stuff you just couldn't do. It was built to serve a very basic set of needs. And the underlying MyISAM storage engine also suffered from corruption from time to time. So you couldn't add data to your indexes. You couldn't delete data from your indexes. You had to go repair them first. And that meant downtime. And while you're doing that on a server, it meant the other servers were carrying a disproportionately higher share of the load. So it was the kind of thing where I was looking at that and trying to figure out, well, what are we going to do to fix this? What are we going to replace it with? Because at the time, I'll just give you this number for context and talk about it later. When we started on this process, there were 25 servers handling search at Craigslist running the MySQL Full-Text search service. And it really wasn't enough because it was still having problems on a very regular basis. So at the time, I looked at the options that were out there. I looked at Solar, Lucene, looked at a couple other lower-level search systems, looked at Sphinx, and tried them all out. I just had to spend a few days with each one, see how approachable it was, see what features it had, see what performance was like, and just tried them out, and eventually settled on Sphinx. Is there anyone here who hasn't heard of Sphinx before at all? Just a few people? Okay, so the best way to think of Sphinx, I think, is it's a very small, focused tool set for building a full-text search service for your website or anything you're working on. What I've seen is that there's a spectrum of offerings out there. On the lowest level, you find some low-level library that if you don't want to build the inverted indexing yourself and build some of the other basic features yourself, you can pull in a library and build that, and then program everything else around that and build whatever you like on top of it. Then in the middle, there are things that come with enough tools to get the job done. They know how to do inverted indexes. They know how to do tokenizing. They know how to do stemming and a few other things. And they give you enough to get the job done, but a lot of room to customize. And then at the far end of the spectrum, there's services, there's software you can download, and it's kind of batteries included. Everything's there. All that stuff's built in. There's an API on top of it. There's example clients in lots of different languages, and it's kind of like there's tons and tons of knobs to twiddle, and you can pick that up and start running with it. So if you're thinking about it in terms of that spectrum, in my opinion, Sphinx kind of falls right in the middle. It's not a terribly low-level system, but it's not all the batteries included if you want to just turn something on today and have it running. But the nice thing is that the learning curve on it was very, very shallow. It didn't take long at all to get up and running. I think I had it up and running in a day, and about 2 or 3 days after that, I had an initial prototype, and I I could walk into my CTO's office and say, all right, I have some performance numbers. I think I know how many searches per second we can handle. I think I know how quickly we can index documents. I think I know how big the indexes are going to be. And it felt good to be able to find something that was kind of in the middle of the spectrum, and it had enough features to get the job done, but it wasn't so complicated that I could get my head around it in a short amount of time. One of the other things that has really been helpful is, aside from being an open source project, Sphinx has a company behind it, which means you can pay someone for support. You can contact them and ask about building new features, custom development, all that kind of stuff. So the quick sort of summary of my thoughts on Sphinx is, first of all, I think it's awesome. I've been working with it for 6 years, and I've just been very, very happy with how it's evolved. Nowadays, it actually speaks the MySQL protocol, which is great for development. If you are already comfortable with talking to MySQL, either from the point of view of querying or from the point of view of adding data, then Sphinx is very easy to deal with. Because to add new documents, to get them indexed, you just do an insert or replace query and send the data in. If you want to query against the index to find documents that match a query, it's a select statement, because you're just using SQL. Now, it's not standard SQL. It's a Sphinx variation of SQL, because full text is a different problem than a normal relational database. But it means that the barrier to entry is very low. It's amazingly fast indexing. I mean, at the time I tested it on many generations older hardware, I was doing 10,000 documents per second, which that's way faster than the rate at which we have to ingest documents. So I was very happy with that, because it told me that we could use Sphinx and have a lot of headroom. We could really grow with it. The queries were also remarkably fast as well. At the time, I remember, I think our average queries were taking 4 or 5 milliseconds, something like that. And that was just, taking queries off the site and running them through Sphinx to see what would happen with them. Like I said, it's very easy to understand, very programmer-friendly in the sense that it's not a big, complicated system. It's a small set of tools that you can put together to do what you want. I already mentioned it's open source. I already mentioned they have great support. We've been a customer of theirs now ever since we deployed it. And we have found our share of bugs. We've had problems with it, but they've been resolved remarkably fast, and never seen a bug creep back into the system. Tests will always get added to the test suite to make sure a bug doesn't creep back in, and things have just continued to improve as time has gone on. And overall, it's been a very stable thing for us. So I mentioned it was a very small set of tools that you're dealing with. If I look at it from the point of view of you download Sphinx and compile it, what binaries do you end up with? I can fit that on a single slide. The main piece of Sphinx nowadays is a process called searchd. That's the server process that you start up. It can listen for network requests just like MySQL. Instead of listening on port 3306, it listens on port 9306 by default. And you can connect to it and start inserting data. You can start running queries against that data. It can operate in a number of different modes. It can be multi-threaded. There's a pre-forking mode. There's a fork-on-demand mode that nobody uses anymore. But at the time, we used the pre-forking mode because the threading implementation originally was pretty basic and needed some improvement. The second most important tool is called Indexer. It's a command line tool you can use to build indexes offline. If you're not going to insert documents into a running instance of Sphinx, you can use the indexer and index large batches of documents very quickly. You feed it an XML document, and as long as the sort of schema of that XML matches the schema you define for your index, you can build those indexes remarkably fast. There's a utility called Index Tool, which can give you stats about your indexes. It can check indexes for consistency and that kind of stuff. And then there's a command line tool called Search, which is just used for running sample queries, again, sort of offline against the indexes you've built. As far as the pieces you get when you download and build Sphinx, and that's about it. The configuration file for Sphinx and the indexer tool is also very, very simple. I'm not going to show you an example of that, but a really basic implementation, you could be a 20 or 30 line config. Start with one of the standard ones it comes with, and you customize, and you're up and running. Any questions yet before I move on? Yes? So the question is, does Sphinx sit on top of MySQL, or is it kind of a separate thing? And the answer is sort of both. So Sphinx can be built as a standalone service, and that's the way that we use it. We run the searchd process, and it runs as a standalone service. But there is a way you can build Sphinx support into MySQL, so that instead of having to know you want to query Sphinx, you can actually send a query to your MySQL server, and MySQL under the hood will contact Sphinx and execute your full-text queries for you. So there's actually really tight integration there between Sphinx and MySQL. The second place you see that is the indexer command line tool if you're building offline indexes. In the configuration file for that, instead of feeding it documents via an XML interface, which is the way we used it, you can point it at a MySQL server. You can specify some select queries that are used to fetch documents from your database, and they're sort of parameterized in the sense that there are placeholders in the query, so that Sphinx will sort of fetch them in groups and then index them. So if you have an existing MySQL server and your schema is such that it's very easy for you to point Sphinx at it, that makes the integration even better. And it's now disco time.
They think you're raving.
So I mentioned that the first way we deployed Sphinx was with a master-slave architecture. And the way we did that is we basically built one Sphinx index per city. Because as you know, Craigslist kind of has a Craigslist for every city that we're in. There's San Francisco Bay Area Craigslist, there's Portland Craigslist, Seattle Craigslist, Dallas Craigslist, Chicago Craigslist, and blah, blah, blah. There's 700 of those. The way we handled growth was very simple. We said we're gonna be shard into 2 clusters, and then over time we actually went to a 3rd cluster. And it was really simple. It's like, okay, we've got 700 indexes roughly. We numbered them from 1 to 700 and said, okay, if there's 2 clusters, all right, index 1 goes here, 2 here, 3 here, 4 here. Very simple. Index number, mod number of clusters, and that's where you go find your data. And then, so that was a very simple way to allow things to grow. At the time, the sort of master in every cluster would build indexes every 10 minutes. Cron job would fire up. A bunch of custom Perl code that I wrote would go look at the database and go, all right, what postings have either been added, changed, or deleted since I last looked? Fetch all those, figure out how to format the data as XML, feed it to the indexer program as an XML document, and it would get indexed. As part of that, I also built a versioning and rollback mechanism. So at the end of one of these runs, we were left with a set of sort of versioned indexes. We used the Unix timestamp of the time that it built, which meant if there was some catastrophic thing, like we hit a bug in Sphinx or something else happened, it was possible to roll back to the last set of known good indexes. And we used that probably half a dozen times when we had trouble. It wasn't a Sphinx bug every time. Sometimes we pushed bad code and it caused the indexing to blow up for some reason. So we'd build a snapshot of indexes. The slaves would then pull their indexes from their master via rsync. We'd restart the searchd process on the slave. And I said we were using a pre-forking configuration, so you'd restart, it would fork off a bunch of children to handle requests, just like a pre-forking Apache would. And it would start handling requests. Now, the hardware at that time, the generation of hardware we're using was like dual processor, dual core, AMD Opterons, 32 gigs of memory, single, I don't know, 200 gig disk or something in that ballpark. That was the kind of hardware we ran on at the time. And this setup worked very well for us. Sort of a graphical representation of that. We've got the postings database over there. All the postings at Craigslist live in MySQL. And the Sphinx master would be pulling from that postings database every 10 minutes to get all the changed and new postings and deleted postings, build its indexes. All of the Sphinx slaves would rsync from the master after the next version of indexes was available. They'd restart, and then all the web servers that needed to query the Sphinx servers they had the logic that they understood the sharding, so they'd know who to go to get the data they needed. Very simple setup. Probably looks a lot like a lot of MySQL deployments where you've got single master, lots of slaves, reads going to the slaves from front-end web servers. That's one of the nice things about Sphinx having so much in common with MySQL and working so well with MySQL is you can use a lot of the same strategies to solve the same problems. So you don't have to invent anything new. So what would happen is we'd get a hardware upgrade after a few years. And sometimes you feel like this guy. It's like, oh, I'm driving a really fast car now. This is great. And so a hardware refresh cycle would come along. And what that did is gave us the opportunity to look at what we're doing and say, all right, the architecture we have is great. It's worked fine for a few years. But is there something about the hardware we've got now that we can take advantage of to do this better? So the answer is yes. Got this idea for something called autonomous Sphinx. And the reason is because when we had that master-slave architecture, you've got a single point, well, multiple single points of failure, obviously. You know, if the postings database dies, that's not good. Now, practically speaking, we were always reading from a MySQL slave, not from the master. But if the Sphinx master for a cluster died, that particular cluster wouldn't get updates. Realistically speaking, the code was written in such a way that we could change one configuration variable, send the new config out, restart, and one of the slaves would just be the new master. They all ran the same code. So it was a simple change, but the annoying thing about that is it's a manual change. Someone had to get involved, make the decision, figure out which box they were going to promote, and actually do that work. So the idea behind Autonomous Sphinx is we've got this new hardware. So the new hardware, if you haven't read already, we've got these new fancy blades. They've got 24 cores in there, 72 gigs of RAM, and 300 gigs of solid-state disk. Just leaps and bounds ahead of what we were using before. It's like with all of that extra capability, can we build the indexes on the same machine that's serving traffic and not have to worry about rsyncing it from somewhere else? Let's just do all the work there, and then all of the Sphinx servers become the same. They don't depend on any other Sphinx servers. There's no master. As long as they can get to one of our many MySQL slaves to pull the data in, it'll work fine. All the data gets indexed. All the nodes get the data they need. They're all completely independent. And if one of them dies, you know what? The sysadmin on call can just look at that and go, all right, well, that machine's dead till morning. No big deal. I don't even need to take it out of the configuration because the clients are going to figure out it's dead. So the idea is that you get some operational simplicity as a result. And simplifies the design. No one has to think about masters anymore. Single point of failure, gone from the point of view of at least the indexing and serving of search requests. And honestly, it's better utilization of hardware. When we first deployed this hardware, we kept the existing Sphinx infrastructure, and it was like the masters would do their index rebuild every 10 minutes, and they were done in 90 seconds, and they sat idle the rest of the time. It's like, well, that's kind of silly. And meanwhile, the slaves were handling the traffic and not even breaking a sweat. It's like, well, they could be indexing while they're serving queries, no big deal. So I went through and made that change happen. And it actually wasn't a lot of work because, like I said, the masters and slaves were running the same code base all along. So we just had to kind of get rid of a bunch of the logic involved in copying indexes around and things like that. And it worked out pretty well. So, we had to ask, is this going to work? Tested it out on a few machines, worked fine, and deployed it not long after. So what did that look like? Well, kind of what I said. There's no master here anymore in between. The Sphinx slaves are talking directly to our slave of our postings database, and the web servers, again, are using the same logic they did before to go and query the Sphinx servers. Yes? Okay, so the question is, when we went to the autonomous model, were we still partitioning indexes into different clusters? The answer is yes, we were. Practically speaking, we didn't need to be at the time because the new hardware had so much memory that we could have fit all our indexes. We could have indexed all the postings on a single box and then just had several boxes doing that, and so we'd have the redundancy. But we kept the split in there. We kept things split into clusters because once you've already done that, it's kind of silly to undo it because you may have to do it again someday. So I think there's a danger in building something and not building in the support for the sharding, not building in any partitioning, because when you have to add it later, it's always harder. So if we were to take that out, it meant that some design decisions might sneak in while we're not paying attention that would come back to bite us later if we had to shard again. No, so yeah, I may have not explained this well. So let's say we had 3 groups of 3 Sphinx slaves. We're looking at one of them. All 3 of these machines have identical data. And there's 2 other clusters just like that. So a third of the indexes live in this cluster, a third in another cluster, a third in another cluster. So we always had redundancy, which is great because if you want to do upgrades on the hardware or something dies, you know, you're covered. Other questions? Okay. So this change we made, it worked great. Everything was working really well. And it was around this time that I was talking to Andrew, the creator of Sphinx, and you know, he was asking me what we were doing, what our architecture looked like, are there features that we wanted, that kind of stuff. And he started hinting at something that he had been working on, which was real-time indexing. The idea behind real-time indexing is kind of what it sounds like, is you wouldn't have to have your indexes built offline, stop your searchd process, load in the new indexes, start it back up, and have that sort of churn going on all the time. With real-time indexing, you would have the searchd process running all the time. You just fire new documents at it at the same time that you're firing queries at it, and it would all magically work. So he had been working on this for about 2 years at the time, and I started experimenting with it after this autonomous Sphinx stuff was all deployed and working and documented and stuff like that. And what I found was really surprising. The real-time search technology in Sphinx had really improved. I looked at it early on when he first told me about it, and I was able to crash it. And it was like the performance wasn't great because the locking wasn't very granular and stuff like that. It was, you know, it was what you'd expect of kind of an early implementation of an architecturally new and significant feature. So what I discovered is this stuff had really matured. Like I said, the searchd restart overhead would go away. And this, you know, this gave me a really good chance to kind of move the goalposts. You know, previously we were building indexes every 10 minutes, and I thought, well, gosh, what if we could have this goal of every posting being indexed within 10 seconds of when it comes into the database? Wouldn't that be something? So started working on kind of a complete redesign of a lot of our code that was used for pulling data from our postings database and giving it to Sphinx. And got rid of the idea of cron jobs for that and just wrote programs that were going to run all the time and take care of managing that for us. This also gave us the ability to eliminate the XML generation code. Does anyone here enjoy writing code that writes XML? No, good, yeah. It's a pain. Now, part of the problem is that unlike a lot of companies, we have code that's been around for a while. And it's code that predates the idea that you might eventually have to deal with multi-byte characters in UTF-8 and stuff like that. So there was some amount of pain just in trying to produce valid XML that Sphinx could consume. Because, you know, we get, you know, anytime you accept user input, people will give you anything they can. So we get all sorts of mess and have to try to figure out what was valid, what wasn't, and what character set they were trying to send us stuff in and deal with weird encodings and stuff. That consumed a disproportionate amount of time maintaining that. So I was happy because I'd be able to remove all of that XML code and just hand data straight to Sphinx. It would act like a MySQL server. I'd just fire replace queries at it or insert queries. And it also allowed us to leverage a lot of our existing libraries because we've got code in place for knowing how to talk to MySQL and deal with errors and things like that. So this seemed like an awesome goal. It was like, I want to make this work. So we did that, and it worked out quite well. One of the things I wanted to talk about here also is I get questions all the time about how we partition our data in another way, which is how many different types of Sphinx installs do you have? Is there one big Sphinx install that everything's cloned from? The answer is no. We actually have several different types of Sphinx clusters. The main one that people interact with on the site we think of as sort of the live Sphinx clusters because it is what is handling your query when you're coming to the site. It's the first thing that's going to get a new posting that comes in and index it. And from the point of view of trying to scale it and keep it running well, it has the highest traffic, the highest query volume, and the highest churn. And like I talked about early on, the churn rate and the volume of stuff coming in are the two things that really become problematic when you're trying to figure out how to scale this stuff. We also have another install of Sphinx that we refer to as our Team Sphinx. That's all of our internal tools that have to do searches on postings use that. So it's the stuff that's kind of not exposed to the outside world. It's the stuff that we query internally. It's the lowest traffic from a query point of view because we don't run that many searches internally. But there's some extra data in there that's not searchable on the website, and it's still getting the same kind of volume and the same kind of churn as far as data coming in. How many of you have ever seen the forums on Craigslist? So yeah, one of the least understood or least recognized and used features we have is discussion forums. A lot of what goes on in Craigslist is actually community supported in the sense that people go in the forums and they'll help each other out, answer questions. Especially you'll see new users discover them and show up there, and they're trying to figure out what the right place to post something is or whatnot. So we've got forums on all sorts of different topics. You know, the active ones have to do with using Craigslist, and you know, there's a help desk forum. There's a feedback forum where people tell us what they're looking for. Well, it'd be great if you added this feature. Oh, couldn't you make it so this works differently? That kind of stuff. But there's forums on all sorts of other topics as well. Everything from politics to animals to whatever, you name it. But we wanted to be able to make that stuff searchable using Sphinx, so we've got a separate cluster devoted to forums. And then that one is fairly low volume. It doesn't get a lot of postings coming in compared to the classifieds. It is fairly low traffic in terms of queries because forums are not nearly as active as the classified side of the site, so it's not seeing as many queries either. That's helpful because sometimes we can experiment with stuff on the forum side because it's just not getting as much load, so it's easier to tinker around there. And finally, we have a Sphinx install we refer to as our archive Sphinx. Has anyone here ever posted something on Craigslist and then come back a few years later and wanted to find that old posting? Has that ever happened? A few people have done that. I've done that too. The reason you can do that is because we archive old postings after they've fallen off the site. Either they've been deleted because you sold your couch or whatever, or the posting just expired. You know, you posted a job listing and it ran for 30 days and then it expired. Well, those live around in our archive. And you can come back, log into your Craigslist account, find that thing you posted 3 or 4 or 5 years ago and pull up the posting again. I know this is very common with jobs because a company will post an ad on Craigslist, hire someone, and then they leave after 4 or 5 years. They go, oh, let's go find that old job posting. There it is. We index all of those old postings using Sphinx as well. So we've got a system that has terabytes of data indexed, and it's constantly growing. Data doesn't get thrown out of the archive, so it's this constantly growing thing that gets bigger and bigger and bigger. And users have the ability to come in and go back through their entire posting history, and Sphinx is what powers that for us. So the reason this slide is kind of here is to illustrate that we're actually, while Sphinx is a full-text search system, and we're using the same real-time architecture for all these different deployments, they all have very different characteristics. One of them is very high churn, high volume, lots of queries. Another one is, same kind of churn and same kind of volume, but not as many queries. And then another one is just sort of much smaller in terms of the volume. And then the last one has just vast amounts of data in it, but doesn't get hit nearly as often. But again, nothing ever gets deleted there. So it's a very flexible tool for us, and we've been able to make it work in a variety of different circumstances. So some of the lessons and some of the sort of innards of Sphinx that we've been dealing with in the last year or so. I want to explain a little bit more about how the real-time indexes work. And if you get interested after this talk and want to go experiment with it yourself, I can probably save you a little bit of hassle. So if you imagine a mythical Sphinx server running on a server somewhere, and it's got one index configured for your data to go into. You start indexing, you start putting data, you start indexing postings, email, whatever it is you're putting in there. The indexes get created just all in memory, and because memory's fast, so why not keep everything in memory if you can? And it gets created as something that's referred to as a RAM chunk. Just a chunk of RAM that's got the index in it that you can search. And there's a configuration directive in Sphinx called rt_mem_limit. And that just sets a cap on how big the RAM chunk can get. Because you need to configure how much memory you're willing to give up for search. And when your index hits that size, what happens is they get converted to what's called a disk chunk. And a disk chunk is just a structured full-text index that happens to live on disk. And as you can imagine, disk chunks are a little slower than RAM chunks because you got to go pull the data off disk in order to search them. They also have the advantage that they are on disk, so they're persistent, so you can back them up, copy them to other servers, do whatever you want with them. And you can kind of keep this process going for as long as you want. You can configure, half a gigabyte of memory, keep throwing data at it. It fills up, gets sent to disk as a disk chunk, call it chunk number 1. The memory that was used for that chunk gets freed up, and then it allocates new memory and keeps doing that again, hits the limit, creates disk chunk number 2, and this just kind of keeps going on. And this is great because you can kind of incrementally build up a large index on documents without keeping everything in memory. And when we first deployed the real-time Sphinx infrastructure, I knew about this. I understood how this worked. But I never thought to put any monitoring in place to know when disk chunks were getting created. It just escaped my mind. And what happened is we had a problem one day where, for some reason, searches seemed slow. The Sphinx servers were all really busy. Query times were kind of abysmal. Queries that used to take 20 milliseconds were taking 100 milliseconds, which is, a way of saying things are 5 times slower than they should be. And it took a while to figure out what was going on because it was still a relatively new deployment, and it didn't dawn on me that we were ever going to blow past that limit and actually create disk chunks. So it took some punting around, and then realized that what was happening is in one of our biggest and most active cities, we had already created 7 disk chunks. That's not that big a deal because we've got solid-state drives in these machines, and you can still read data pretty quick. Seek times are basically nothing. But the problem was compounded by particulars of the fact that this is a Craigslist city. These are Craigslist classified postings, and we've got the really, really high churn rate. So what was happening is a query would come in, and someone would come in and search for Honda Civic, and Sphinx would go and check the chunk that was in memory, the RAM chunk, and go, yeah, there's 1,500 matches here. Oh, disk chunks, so I had to go look at all the disk chunks. So it would go run that query against all those 7 disk chunks, and it would find thousands more matches. But the trouble is, almost all of those ads had already been deleted. So it was doing all this extra work to find a bunch of stuff that it had to throw out anyway because it had already been deleted. It's just that those disk chunks hadn't been cleaned up yet. So once you figured out what was going on, there's a very simple process where you go to Sphinx and say, optimize that index. And what optimize means is, if there are any disk chunks, go through them, find any deleted documents, and get rid of them. Any Postgres users in here? You can put your hand up, it's okay. Okay, this is Sphinx's version of vacuum. You've got to get rid of all the deleted stuff. And as a byproduct, what it does as well is if you have multiple disk chunks, it'll actually take pairs of disk chunks and merge them so you have fewer disk chunks to look at. So basically, we were just missing some basic housekeeping that wasn't in place. So ran that optimize against the index. Query times went from 100 milliseconds to 60, and ran it again, and went down to 30 or closer to where they should have been, and learned a very important lesson there, which is we needed to get a handle on this stuff. So other lessons we learned along the way, things that changed through the evolution of the way we were doing search. Stop words. So a stop word in search is a very simple concept. When you're indexing a document, the conventional wisdom had been that there are certain terms that are so common that there's no point in even indexing them because they don't help when you're searching. And I'm thinking these are words like the letter A. If you're indexing web content, HTTP, href, IMG, stuff like that, things that you could see in any web page. They're just so common that it's not really going to help. The trouble is that Google has spoiled us. If you try and do a Google search and you type in, the quick brown fox, it's going to find websites that have the quick brown fox in them, not just quick brown fox. It's going to use the. There are no stop words. Like the notion of stop words for most people's brains went away a long time ago. They've been trained to expect search to handle every single word they can possibly think of to type. When we initially deployed Sphinx, we had a list of stop words, and we had followed the recommendations that were in the manual, which was Well, index all your content, use this little command line tool. It'll dump out all your terms in your index and sort them by frequency. Look at the top 10, top 20, top 50, make those your stop words. Everything will be faster. Well, it was marginally faster, but it was less useful to our users because we had a list of 50 stop words, and some of them contained very common things that people actually wanted to search for, and their searches weren't behaving right. So along the way, we kind of got rid of stop words. They weren't worth the trouble. And the reality was the new hardware was powerful enough that the performance difference was in the noise. It just didn't matter. I mentioned the lack of monitoring. We had to monitor everything. When that event happened, it was a very frustrating couple of days, and had to step back and think, all right, what else are we not monitoring? What else can we be checking for? This happens when you deploy anything new, but monitoring for disk chunks was an important thing. We set up monitoring to look at, for all of our in-memory indexes, it's like, okay, how close are they to being full and even generating a disk chunk so we can see it before it even happens. So our RT mem limit, that was the one variable I had to change to try to keep stuff in memory so we weren't creating disk chunks. With the goal of keeping it all in RAM. RAM is the fastest thing you've got, so keep it all in RAM. Another thing that we tried to do along the way is to make reindexing data easier. And the reason is, the easier it is to reindex your data, the more you can iterate on what you're doing with search. Typically, the reason we'd have to reindex something is either we changed the logic associated with how we were generating the data to go into search, but more commonly, it's because we were adding new fields to index. How many of you like doing alter tables in a big MySQL database? Well, come on, it's so much fun. Yeah, so it sucks, right? Doing an alter table on a big table in MySQL sucks. Whether you're changing the definition of a column, whether you're adding a column, dropping a column, adding an index, whatever it is. Well, with Sphinx, it's the same thing. It's like you've got to go get all the data and process it again and build new indexes because you've added some fields to it. So part of it was making that process as easy as possible. That made it less painful to iterate, so we could just try things. And the follow-on piece to that was we had to automate our cloning process. And by cloning, I mean when you want to build new indexes, you don't do it on all the servers. You build it on one in each cluster, and then once that server has new indexes, you tell all the other servers in that cluster, hey, go clone indexes from whoever has the newest ones. So automating that also helps a lot because just trying to get rid of all the manual steps along the way. Not only are they just a pain to do, any manual steps is a place you can make a mistake and screw up. And I've made my share of mistakes and screwed up and had to reclone a server or clone from the wrong server and the queries weren't getting answered right, stuff like that. So this is kind of where we were a few months ago. There were a few more lessons that came up very, very recently. What happened is a few months back, another feature in Sphinx matured that I wanted to take advantage of. So I'm going to step back for 1 second and draw one very simple distinction. When you're putting data into Sphinx, just like in MySQL, everything's going into a particular field or a column in MySQL. And every column has a type in MySQL, every field has a type in Sphinx. Broadly speaking, there's only two types to worry about in Sphinx. It's either a column with text that's getting full text indexed, or it's an attribute. So full text columns, you're going to write queries against where, contains this word, not that word, and this word near that word, whatever. And all of the attributes that you store are simply used for things like filtering and sorting. So a Craigslist posting, you may have a field for the title, a field for the body, and then you may have attributes for things like the date the thing was posted, the asking price, the category it's in, stuff like that. So those are attributes. But the trouble is, every time you wanted to add an attribute, you had to add a field, and every time you had to add a field, you had to reindex. Every time you had to reindex, you had to reclone everything. It took a while. Even with all the automation in, it was like, it took a day or so in order to do this. And in order to build some of those new search features I showed you very early on, we were going to be adding attributes all the time. You want to make auto car type search more functional? Well, you want to add attributes on title status, number of cylinders in the engine, paint condition, paint colors, all sorts of stuff like that. So the feature that exists in Sphinx that I want to take advantage of was something called JSON attributes. So the idea is there was a new attribute field in Sphinx that instead of putting a single piece of data into, you would actually insert a small little JSON document. And that JSON document would be, you can think of as like a nested document inside of a single field in Sphinx. Any Mongo users in here? So yeah, like in Mongo you can have subdocuments, same kind of thing. So what that did is it gave you a single place to shove all your new attributes without having to rebuild indexes, which is great. It's like, talk about being able to iterate on the fly. You want to add new attributes, we put them on a little config file somewhere, we update the code, we restart some web servers, and boom, they're live. No re-indexing, none of that. Everything just sees them, and it works great. So a lot less re-indexing, a lot less manual operation, a lot less recloning. Things were kind of on autopilot. It's like I just didn't have to worry about stuff for quite a while. Now, of course, there's a space trade-off. You're inserting JSON in there. It's storing the full field name for every JSON field you're throwing in there. But you know, we had the capacity. It wasn't that big a deal. The recent discovery, however, is that if you do this over the long term, we end up with memory fragmentation problems. What that means is you rebuild indexes, you get all the JSON stuff configured, you start your searchd process up, and you're like, oh yeah, that process is using 8 gigs of memory, great. I got a few of these processes, the box has tons of memory, no problem. Come back 2 weeks later, it's using 10 gigs now, that's weird. Come back 2 weeks after that, it's up to 12. 12 gigs, that's like double what it was a month ago. It's not swapping, we've got memory, no big deal. Yeah, it's never been a problem before. You come back 6 weeks later, that's weird, it's at like 16 gigs now. This doesn't look good. So what we found is that by setting that RT mem limit too high and never creating disk chunks, the memory was all getting fragmented. And so it was using more and more space. Remember, we've got that high churn thing going on. A lot of stuff goes into Sphinx and lives there less than a day because the posting goes live, gets deleted, posting goes live, gets deleted a few hours later. That memory was never really getting reclaimed. So we thought we were in this great nirvana, just sort of hands off, Sphinx runs all by itself, nothing to do, and suddenly it's just like, oh, these boxes are starting to swap. Oh, that sucks. Now what are we going to do? So now we're experimenting with the idea of trying to find a sweet spot between setting RT mem limit just high enough that most stuff stays in memory, but the busy active cities that have tons of data, we're going to let them create a disk chunk or two and just see what performance looks like. Because as soon as you create that disk chunk, it frees up all that old memory and then reallocates it, and you don't have a fragmentation problem anymore. So I don't have an answer to this one. The experiment is ongoing. I'll know the answer in about a month because it takes time to let things fragment and then play some query streams back and see what's happening. But this kind of goes with the whole theme of what I'm talking about, which is we've been able to kind of evolve and just keep working with things as time has gone on. And yeah, the problems we're solving sort of change. You know, you fix a problem here and then let things run harder and faster, and then a new problem over here appears. But we've been able to just keep that evolution going and adding more features as we do it. I gave a version of this talk a few months ago at the Open West Conference in Utah. Were any of you there by chance? Okay, I didn't think so. So a question that came up, I had like 5 people all come up after the talk and ask the same question. And so I thought I should address that as well. Everyone said, why didn't you use Elasticsearch? Have you used Elasticsearch? What do you think of Elasticsearch? So at Craigslist, we do use Elasticsearch. We use it for a piece of software called Logstash. How many of you know and use Logstash? Yeah, it's great. I'm really happy with it. I built a whole Sphinx dashboard to watch our Sphinx query performance on Logstash. It's awesome. Elasticsearch is the component underneath of Logstash that handles indexing, consuming and indexing all that data and making it useful. So everyone want to know what's my opinion? Well, the first thing I had to say is, A, Logstash didn't exist. Elasticsearch didn't exist back when we were doing this work initially. So, you know, we couldn't have chosen it back in 2008. But remember I talked about that spectrum of things where you've got the low-level library here, you've got something like Sphinx in the middle, and then you've got the batteries included, everything, including the kitchen sink over here. Elasticsearch is here. Everything included, lots of knobs to twiddle, kitchen sink, it's all there. when you put data into Elasticsearch, it actually keeps the whole document as well as indexing it, and can automatically do things like analyze the document and use it for updating another index that could be used for using type ahead suggestions and autocomplete and all that kinds of stuff. Like there's tons of stuff in there, which is awesome if you want to get your stuff off the ground. You kind of have a small data volume or small data flow coming in. But from my point of view, it's way more complicated than Sphinx. If I wanted to understand how to keep Elasticsearch running in an environment like ours, I think it would take a while. I'd have to understand what all the knobs are. What is the impact of changing this one thing here and this one thing over there? Are we even using the right hardware configuration? Does it make sense to use Elasticsearch? Because we've designed things around Sphinx for the last 6 years. That said, I think the whole batteries included thing, nice REST API on top of it, all these other little features you can take advantage of is great. I would need to spend a lot more time and get a lot more experience with it before I could say anything more definitive than that. I love the fact that it's sitting underneath of Logstash because we've got all this capability internally. But if I was to try to expose that data set to millions of users a day, I'd have to think really hard about the right way to do that. Whereas I know with Sphinx, there's a fairly small set of parameters I can tweak, and I have a good sense of what they're going to do and what impact there's going to be. How many of you here are using Elasticsearch? A few people. Does anyone want to add anything to this? Who's had more experience with it? What's that?
I love them both.
Love them both. You use them for different things, right? Okay. Yeah, I didn't want to put that in here and say that, but I do have a thing against Java-based stuff for some reason. I don't know. Yeah. I'm just not a fan of it. It's a personal bias. So that's kind of one thing I wanted to throw in here at the end because this came up a lot the last time I gave a presentation like this. So. Because of the garbage collection in the JVM, I wouldn't have a memory fragmentation problem. That's probably true. Yeah, that's a good point. So I've got time now to answer questions either about what I talked about or about things related to what I talked about. Before I do that, I do want to point out that Craigslist is hiring, like everyone else, looking for front-end developers, sysadmins, back-end developers, QA, QC, customer care type people. We've got job listings on the site. Go to the jobs area, search for Craigslist, you'll find them. If you want to send a resume, the easiest email address I can give you is letter Z@craigslist.org, and I'll just send it to the HR folks. There's a web page here that describes what we're hiring for and what working at Craigslist is like. And with that, I have time to answer questions.